In this video, we're going to work with text and see how we can use it in RapidMiner. Now, you've probably heard the term text mining before, and in reality, what we're doing is we are processing the text or pre-processing the text to convert it into a set of features that we can then use with our typical data mining algorithms. So let's see how we can do that in RapidMiner. I'm going to work with a data set here called job skills. So if we look at that and open it up and take a peek, we can see we've got the company ID, the title of the job, the category of the job, the location of the job, minimum or the responsibilities. So here we've got some text fields that we're looking at, the responsibilities, the minimum qualifications, and the preferred qualifications. All right. So here we've got three basically free-form text fields, and we might want to do some analysis based on the text that we see in there. We could analyze each column individually, or we might decide to combine the text from all three of these. Let's go ahead and take that approach because that'll simplify what we're trying to do. So we'll bring our job skills in. And then I want to concatenate two fields or two attributes together. So you can see here, I'll say the first attribute will be the minimum qualification. The second attribute will be preferred qualification, separated by a little line there. All right, so let's go ahead and connect that to the wall and see what we get when we run this. All right, so now I've got my minimum qualifications, my preferred qualifications, and then this combined field that basically crams them together. Now, because I have three, I'll want to do this again, so I'll bring this in again after here. And of course, we would want to rename these operators and document them properly. In this case, now I'm going to make my first attribute my newly combined minimum and preferred qualifications, and then my second attribute, I'll make the responsibilities. So at this point now, I've got responsibilities, minimum qualification, preferred, the combined two, and then finally, all three combined, minimum, preferred, and responsibilities. Okay. So in this case, we're doing a little bit of data prep just to get the field the way we want. Let's take one more look at this output and look at it this way. And we'll see right now I've got my minimum qualifications, preferred qualifications combined is a nominal field. Okay, before we had three polynomials. These are polynomials. These are nominal. All right, so we've got a little bit more work we want to do. First, we can now do select attributes to get rid of those original nominal fields that we don't really need anymore. So I'll do a select attributes. And I will exclude the attributes I don't want anymore. And let's see, we'll take away the first combined, the original. Let's take out the job title itself, just which leaves us with the category of the job, the company of the job, the location of the job, and our combined concatenated fields. All right, so now once I run this, I now have more compact data set with text fields that I can work with. All right, but you may have noticed this is still a nominal field, and I haven't set any kind of a label either. So but at this point, I'm not sure exactly what I want to do yet. So at this point, I'm going to convert nominal to text. And I'll take that single field, the attribute, the combined qualifications and responsibilities, and convert that to text so that now when I run it and take a look, everything looks the exact same in my data set. It's rearranged to put this as my beginning first field. But now when I look at it, it's now a text field rather than a nominal field. All right, so I'm going to take all this and I'm going to create a sub-process. And we'll just call this sub-process initial prep. And I'll bring everything in here to my initial data prep. So now I can run this, verify I've still got the exact same output. Okay, everything looks good. Now I'm ready to start my text processing. So let's go in and see how we can do that. If we go into our extensions, you'll see, depending on how many extensions you have installed, a number of different folders, and here's one called text processing. So I'm going to create a new sub-process. I'm going to process documents from data. And when I bring that up here, you'll see it connects automatically. So each of these rows in my coming out of the initial data prep are going to become an example that gets fed into this sub-process. And then once I'm starting the sub-process, I can perform any text pre-processing that I want to. Okay, so one of the first things I'll probably do is transform the case. Okay, so we'll say, let's go ahead and transform the case. We'll make everything lowercase. Okay, next I can do some stemming. And you see I've got a number of different ways to stem. There's the Levin's algorithm, the Porter algorithm, a snowball approach. Porterization is a pretty commonly used one, so we could put that one in. And as a matter of fact, we could actually run this each time and just see what we've got coming out. Stemming and portering, you can see there are no parameters to display. The dictionary is built into the operator. With transform case, I do have the ability to make everything all lower or all upper if I prefer. Okay? And then I do have the ability to bring in my own dictionary if I want. In this case, I would feed the documents into that, but I would have to have some kind of a stemming dictionary that's been created for me. I may have an industry specific one that I want to use, but in our case, we'll just go with stem porter, using the porterization approach. Another thing, when we go to the process documents, it's going to create a word vector for us at the end based on what we do, and we can choose which measure to include. So you probably recall having some discussions on how to enumerate terms in your text, and term frequency, just a count. Does it occur? Binary occurrence, and TF-IDF. So TF-IDF is pretty commonly used and a really strong approach. So we'll start with that. You have the option to actually keep the original text, or if I leave this off, the original text field goes away and it will be replaced by whatever text pre-processing I decide to include. So you can keep that original text, and you can even do some pruning if you want, so that nothing shows up that, for example, appears in less than 3% of the documents or above 30% in this case. And I could change those, or I could choose an absolute number of documents, or by ranking, ranking in the 5th to 95th percentile. So you've got a number of different options to determine how many features that you keep in. If we start with none, we would get everything. Okay, so we're at process documents and we've stemmed the data. The next thing we probably want to do is eliminate the stop words. So if I go filter stop words, and again, you can see there's an English version along with a couple other languages as well, and I can also supply my own dictionary. So that's almost always an option where you can provide your own dictionary for different text handling operators. All right, so I filter the stop words. Okay, this is going to eliminate common words like a, and, the, and so forth. At this point, I've done a fair amount of pre-processing. What I can do next is, now let's go ahead and start creating the tokens. So what we mean by tokens is we're going to split out every single word and then see which documents that word appears in and what the TF-IDF value for that is. All right, so let's go back up here and run it. First thing to do is, if I look at job skills, I can see I have 1,250 examples. So let's go ahead and run this and see what we get. Now you remember we ended up having 4 attributes when we finished, one of which was that concatenation of 3 text fields. All right, so we click yes. And now we can see we now have 5,461 attributes. And then we have the original 3 attributes, and then we start to have attributes made up of single words. And I'll just skim through those so you can see just a variety of words all around. So 5,461 minus 3 word attributes. Okay. Now at this point, I might evaluate that whole dictionary. As a matter of fact, I want to see the word list. So let's take a look at that word list. So now I can see every word. And of course, its attribute name is the word. How many times does it occur? And then how many documents does it occur in? So now you can start to see which words are, more or less common. And somehow did not get filtered out with the stop words. We might want to see about maybe getting rid of that somehow. So you can see there can be many round trips when you do text analysis. And then what was the most? Yeah, the same thing with the document occurrences. And then we can also do this the opposite way and say, well, in which cases did we only have it show up once? If that happened, this might be something that we are not all that interested in keeping. So 1 or 2 documents out of 1,250 may not be as useful as we'd like. Okay, so that's what happens to our data set. Now, one other thing we might want to do is, once we've created the tokens, we may decide, well, let's go ahead and create our n-grams. And I think that might be under generation. No. Under transformation. So under transformation, I could say generate n-grams, and I want to do this based on the words, not characters. So if I plug that in here, now I will see we are going to evaluate every pair of words that occurs. And then we will generate a new attribute for every pair and see how often those occur. So let's go back up to our main process, try running this again. And this will make the process take a little bit longer. Down here we can see basically how far we have gotten into the run. All right, when it's complete, now we can see our word list. And if we go to our example set coming out of process documents from data, we now have 52,788 attributes. So the number of attributes has exploded now that we've included the n-grams. So we've got an n-gram here of A and ability. We also have the original token A. And then we could do n-grams up to whatever. Let's say we decide to take that up to 3. And then if we run that, all right, so that one took 45 seconds or so to run. And we've got a word list that I guarantee you is longer than it was. And now we have 139,224 attributes. So we now have word combinations of 1, 2, or 3 words strung together. And again, you can see this is very sparse data with zeros for most of the values, and then our TF-IDF score for when it shows up in an individual document. Now, in order to save a little bit of time, I'm going to take the n-grams out, and we'll just go with the original one-word tokens. And yeah, so we've got a good cross-validation. We're going to build a decision tree. We are going to apply the model and check the performance. I also like to see the weights, but out of cross-validation, it's tough to send the weights directly to a port here. So it doesn't show up. So I'm going to take advantage of a couple other operators that RapidMiner has. And these allow me to remember something and then recall it later on. So remember, so I'm going to drag this in here and tell it to remember the weights. So what I do is I can give it a name. I'll just call this model weights. But I have to tell it what kind of data object I am asking it to remember. So in this case, it's going to be attribute weights. And you can see there are lots of different things that you can have RapidMiner remember across your process. And now when I come back out here, I can say, okay, now I want to be able to recall those model weights that I saved earlier. And take a look at them. All right. So now I've got cross-validation, 10 folds for decision tree. Oh, this is a good example. So decision tree defaults to gain ratio, and that's what you can see 71% of the people tend to use. Let's see what happens if I run that with gain ratio. All right, my decision tree basically just has 2 attributes that apply to it. And look at my performance. My accuracy is 14.08%. So now I do have a lot of job categories that I can assign. So that seems to be better than random. But let's see if I tell my decision tree instead, and you'll see information gain that we've talked about before. We've got a couple of others. What if I said I want to focus on accuracy? So now let's try that. I'll run it again. And the cross-validation will run a little bit longer this time. And now you can see there are many more attributes that play a role in this decision tree model. If I sort them by weight, the most important attribute, that is the word in our word vector, is enrolled. We've got ambiguous, agreement, actions, critical, background. And now our accuracy has gone up to 46.08%. And then if I take a look at the decision tree, I can see here's what it looks like. I'll do a tight tree. Yeah, so it's a reasonably complex tree, and you can see interaction shows up first, and then other branches have different splits. So we can then build our model just like we have in the past using any type of approach. So that is doing our process documents and creating tokens, word tokens. We used TF-IDF in this case, and you were able to see how the data set got bigger as we added more, as we made n higher in our n-gram value. All right, so let's get back and see what we'd like to do next.